Alright, so in this video we're going to go over how to multiply polynomials together. And really we're just going to worry about multiplying two different polynomials together. So we won't be multiplying 3 or 4 at a time. For now we're just going to be multiplying 2 together. And this is something that you've already done actually. So this example here is what you would either use the FOIL, or if you use box, you would use box method. So either of those two methods is how we would expand this, or is how we would multiply these two things together. Now each of these are actually polynomials because they have 2 or more terms. So this is multiplying 2 polynomials together, and again how we did that was we did the box method. We copied down x plus 3 on the top, we copied x minus 4 on the left side, and then we went through and filled in the box with the multiplication. So when I write a 3x here, the 3x comes from multiplying 3 times x. So whatever makes up that box is what you need to multiply together. So this box here is made up by a -4 and by a +3, so we would multiply those together to give us a -12, and then in this we would have a -4x. Okay, so you're going to see here in a little bit your exponent rules are going to come into play a little bit. So there's one example, and let's say we have something like, let's say we have 3 terms times something with 2 terms. How about just something easy, x plus 1. What this means is now, since you have more terms, your box will no longer be the same size. So it's not going to be a 2 by 2 box. It's actually going to be a 3 by 2 because of the number of terms we have. Whoop, I messed that up. There we go, a 3 by 2. And why we need 3 is because this polynomial up here has 3 terms, so we have room for all 3 terms. 3x squared, a 4x, and a -1, and up at the top you're going to copy down the other term, or the other polynomial. And then the same idea, you just have more boxes. So a 3x squared times an x, that's 3x to the third. That's one of your exponent rules of a base to a base. 4x times x is 4x squared, and then x times -1. And then you're just going to go through here and fill out this box. And then when you go to combine your like terms to write out your final answer, you're going to have a little bit of extra combining to do than you normally would. So over here, I didn't actually finish it. Those are the only things you would need to combine together. So your final answer would be a x squared, and combining those together, we'd get a minus x in the middle, and then minus 12. Here, we're actually going to have more than that to combine together. And I'm going to highlight this for you here. You're going to have your x's, which are right here. And then you're going to have your x squareds, which are right here. So there's actually going to be 2 different things we're combining together. I will just write that all out in one step. And usually when you write this out and you write your final answer, you go from highest power to lowest power. So we're going to start with the 3x to the third. And then we would write our x squared. So we would combine what I shaded there in green, and we would combine them together to get a 7x squared. We would combine what's in the blue there together to be a 3x, and then a -1 there at the bottom, and that would be your final answer. So that's how we're going to multiply polynomials together. It's just the box method. It's just the box might get a little bigger here. It might have more blocks to fill. So the next slide here is going to be helpful for figuring out when you can use box or when you can just distribute. Okay, because this is something that sometimes gets pretty confusing for most students. So here we have the first example here that's underlined. It's a monomial times a monomial. It means 1 term times 1 term. So that's actually not multiplying polynomials together because a monomial is not considered a polynomial. So all we would do here is we would be combining things together by multiplying. So really I would just take the 4 times the 2 first, then I would add a page by accident. Then I would combine the x's together, so I put the x squareds and the x together, and then I would combine the y's together. And again, it's all multiplication, so this thing is just going to be 1 term, and I'm just going to be multiplying like variables together. So 2 times 4 would be 8, the x squared times the x would be an x to the third, and the y to the fourth times the y would be a y to the fifth. That's kind of a review from the last section we did about your exponent rules. Here, the second one, this would basically be like the distributive property. Now, you could also use box. It would just be a small box. But if we use distributive property, we would have 3x times x, which is 3x squared. And we would have 3x times 3, which is 9x. And that would be our final answer. Or again, you could actually use the box there. You would just have a 1 by 2 box because you have a 1 term and then you have a 2 term. Then you would just fill your box in here and you would get the same answer. Okay. And the last one is actually where you're going to be using the box method. If you have a binomial times a binomial or even larger, something with 3 terms, then you're always just going to use the box. So basically you can use the box every time unless you have something like this first example up here that I just highlighted. And technically you could use the box here. You would just have 1 box though. Because you have 1 term in each. So you would be writing your box like this. And you could do that, but really just to fill that box in, you're just doing the whole problem. So that's why we really wouldn't use box, but you can write it out if you want. But for this bottom one down here, same thing, just did this one on the last slide. You just fill in here. And then you would combine like terms, write your final answer, x squared plus 2x minus 8. All right. When you multiply, you have to do the box method. All right, that's fine. What did I? Let's see. But when you difference each, we want to skip that. Addition, subtraction. We've been over this one. Basically, when you're adding and subtracting, you're just combining like terms together. So if this first example, 2x plus x, that's just 3x. The second example, we're combining our x's together to get 7x, and we have nothing to combine the 3 with, so it just stays along. And this last one, we actually are going to have to distribute that negative. So this is 3x minus 4, and then we're going to distribute that negative, so we have a minus x and a minus 3. Then we would combine like terms. We would combine like terms, that would get us, say, 2x minus 7. All right, so when you're adding and subtracting, you're just combining like terms, and that's what makes multiplying a bit harder. So let's just go through here. Can we combine like terms? And this is just a review of how we combine like terms. What are like terms? First of all, I can't combine like terms if I don't know what they are. Like terms, how do I want to say this? All variables must be the same. And by that I mean all the variables and the exponents in the terms have to be the same. So variables and exponents. So what do I mean by that? Well, let's check out this first example. In this first term, to combine these together, this is an x squared y, but in the second term it's just an xy. So you cannot combine those together because of your x, right? Your x squared in this first term here, it's a squared, but in this term it's an x, so that means they can't be combined together. All right, now if this was a squared, there was a little squared there, then I could combine these together. And what I would say is, well, when I combine them together, I'm still going to have x squared y's, but how many of them do I have? Well, what you did here is you had 1 and you added another one, so it's just 1 plus 1, so you would have 2. All right, but again, that squared wasn't there, so that's just a big no. All right, second one, do the variables match? Again, variables and their exponents. Yes, they have an x squared and a y squared, so these do match. So what that means is my answer when I combine these together, it's still going to be an x squared y squared, and then you're just going to have to figure out how many there are. Well, how many did I do? I did 3 to start, and then I took away 2. So what is 3 minus 2? 3 minus 2 is 1. I could put a 1 there, but that's really not necessary, so I could just take that 1 away there, and still the same answer. And this last one, are any of the variables the same? Well, this is an xy, so in order to combine something with this 13xy, I would need something else with an xy, which I don't have. This is just y, this is just x, so nothing matches here, so again, this is a no, I cannot combine like terms there. Alright, and let me just write one example here. Let me add one for you guys to do here at the end. I want you to multiply these together. 3x to the third plus 2 times x minus 4. Okay, so go ahead. What you're going to want to do here, I will give you the first part, is you're going to need to use a 2 by 2 box. All right, let's go ahead and again fully simplify that and then answer the question. Thank you.